Ant colonies exhibit remarkable collective decision-making when environmental threats like drought or predators emerge. Scout ants assess conditions using their antennae, detecting humidity and chemical signals. Research shows that just 5 to 10 scouts can trigger migration for colonies of thousands. This mirrors human societies where a few leaders mobilize entire communities during crises. The process is democratic. Ants vote by following the strongest pheromone trail. Ants communicate migration routes through chemical pheromones, creating glowing, invisible highways. Each pheromone type conveys specific instructions: alarm, direction, or food sources. Studies reveal that these trails can persist for hours, guiding thousands efficiently. This system parallels human road signage, but with 100% participation. The colony's survival depends on every ant accurately interpreting and reinforcing these signals. Ant migrations showcase sophisticated labor division. Soldiers with enlarged mandibles guard flanks, while medium workers transport larvae in their jaws. The queen is protected at the convoy's center, attended by caretaker ants. Remarkably, injured ants are carried, a rare altruistic behavior in insects. This mirrors human refugee movements, where medics, guards, and carriers each have defined roles for communal survival. Migrating ants move in synchronized rivers up to 10 centimeters wide, maintaining a steady 20 centimeters per minute pace. They optimize paths using mathematical efficiency, always finding the shortest route between obstacles. Research documents colonies traveling over 100 meters, equivalent to humans crossing continents on foot. The entire colony moves as a single superorganism, constantly adjusting formations like fluid dynamics in action. When encountering gaps, ants demonstrate stunning engineering. They build living bridges by interlocking legs, withstanding weights 100 times their collective mass. For water crossings, they create buoyant rafts using their water-repellent bodies. Scientists estimate these structures self-assemble in under 3 minutes. This rivals human emergency bridge building, but without centralized command, pure decentralized cooperation. Ant colonies employ layered defenses during migration. Soldiers release alarm pheromones, triggering coordinated attacks, biting with 5,000 times human bite force relative to size. Some species spray formic acid up to 10 centimeters. Workers immediately form protective circles around the queen and larvae. This resembles human military tactics, but with instantaneous communication and zero hesitation in self-sacrifice. At night, ants form living bivouacs, temporary structures of interlocked bodies. These maintain 30 degrees Celsius internal temperatures despite external cold, protecting larvae. The structure breathes through controlled gaps, adjusting to humidity. Researchers found that worker ants rotate positions hourly to share heat exposure. This compares to human refugee camps, but with perfect resource distribution and zero waste. Ants navigate using polarized sunlight patterns invisible to humans, maintaining course even under cloud cover. Desert species like Cataglyphus measure distance by counting steps. They integrate this data with sun position like ancient sailors. Experiments show displaced ants immediately recalibrate using backup scent trails. This dual-system navigation surpasses early human maritime technology in reliability. Upon arrival, workers excavate 3D tunnel networks with precise humidity control. The queen's chamber is strategically placed at optimal temperature, 25 to 28 degrees Celsius. Food storage areas are designed to prevent mold. Some species even use antibiotic-producing bacteria. This construction occurs 50 times faster than comparable human projects relative to size, all without blueprints or leaders. Ant migrations showcase nature's most efficient collective intelligence. Their systems achieve what human societies strive for: perfect resource allocation, zero unemployment, and unanimous cooperation. Research suggests studying ant algorithms could revolutionize human logistics, from traffic management to disaster response. Ultimately, these tiny creatures demonstrate that survival depends not on individual strength, but on the wisdom of the collective.